Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but I'm going to title it how I titled the title. But what I am sure of is our one goal for the day. And our first goal is going to be to draw quadratic expressions. And let's go ahead and review. A quadratic is a polynomial of the form ax squared plus bx plus c. It's called a quadratic, quad meaning 4, because it has a square in it. Now, there's a few rules about the numbers a, b, and c. A is not allowed to be 0. It can be any number besides 0, because once a is 0, you don't have a quadratic, you have linear. B and c have no restrictions. They can be whatever number we want. So what we're going to do is we're going to create quadratic expressions by multiplication. Now, this approach is a purely visual approach. And the hope of this series of lessons is that you will be able to visualize the quadratic and then factor it. But in order to visualize the quadratic as whatever shape it's going to be, we need to learn how to make that shape from its factored parts. So we're going to learn how to build a quadratic and then kind of reverse engineer a way to picture the quadratic in our head, and then ultimately factor this, and then this series of lessons is going to lead to a discussion about how to manipulate the ultimate shapes that we get into a very specific shape and allow us to solve these quadratic equations in what I believe to be the most efficient manner. But that's quite a bit away, but we must start with the ability to represent x plus 2 times x plus 3 as a picture, same thing as x plus 4 and x plus 2 as a picture, as well as x minus 3 and x plus 5 as a picture. So I just need us to represent this as a picture, and then from that, explain what we have. All right, so it's really easy to do. I have 3 examples. It's not very difficult. And so what I'm going to do is I'm going to represent this horizontally. I'll represent this vertically. So from here to here, I'll call that length x. And then from here to here, I'll call that length 1, and I'll add 1 more because I have x plus 2. So this is x plus 2. Now I need to make this vertically. Again, I'll have the same length for my x, and then I'll have my length for my 1. So 1, 2, and I have 3 of those guys. And this is my x plus 3. Now to multiply this is very easy. We just extend the lines and count. Alright, so I'm going to extend this line down to about here, extend this line down to there, extend this line down to there, extend these over. You hear people are glad the school day is over. Alright, so let me help you interpret this, okay? X times x is going to get me to x squared. X times 1 is going to give me x. X times 1, that'll give me x. 1 and x gets me x. 1 and x gets me x. 1 and x gets me x. 1 and 1, 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 and 1 and 1. These all get me 1. So let's just count what we have. Alright, so I have 1x squared. I have 1, 2, 3, 4, 5 x's. And I have 1, 2, 3, 4, 5, 6. And I have 6 small boxes. Alright, and this is a quadratic expression that I've drawn. This shape represents this. And again, hopefully we'll see through this that it's actually a little bit easier to work with quadratics if you can visualize the shape that they make. And hopefully we start to recognize a pattern with the numbers that we have in our expression and how the shape itself is built. All right, let's try this one. It would probably be a good idea if we hit pause and gave this a shot and see if we could do this as well. So hopefully you hit pause and you gave it a shot. But if not, here we go. And if you did, good. So there's my x, and I need 4. So there's 1, 2, 3, and 4. That's my x plus 4. And vertically, again, I'm going to have my x, and my 1, and my 2. So that's my x plus 2. And again, I just extend lines. All I need to do. Extend this, extend this, extend this, extend this, and extend this. One tip, definitely make the length of x way different than the length of 1. If you make them the same, you're not going to be able to differentiate later on. So let's extend these lines now. Alright, so x and x gives me x squared, x and 1 gives me 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 x. 1 and x gets me x, 1 and 1 gets me 1, 1 and 1 gets me 1, 1 and 1 gets me 1, 1 and 1 gets me 1. 1 and x gets me x, 1 and 1 gets me 1, 1 and 1 gets me 1, 1 and 1 gets me 1, and 1 and 1 gets me 1. So let's just count the way up. This rectangle represents x squared plus 1, 2, 3, 4, 5, 6x plus 1, 2, 3, 4, 5, 6, 7, 8. So this would be how I represent x squared plus 6x plus 8. All right. One more example. This last example is a little different because it has negatives in it. All right. So why don't you go ahead and see if you can try this one. I hope that you hit pause and give it a shot. If you did, I'm back. And let's just go ahead and give this a shot. So here I have my value of x. There's my minus 1. There's a minus 1. And there's a minus 1. And let's go vertically. I wish I would have made it a little bit smaller, but that's okay. There's my x. There's my 1, 2, 3, 4, 5. All right, so again, we just extend the lines and it multiplies it for us. All right, so let's see here. X and x gets me to x squared. X and negative 1 gets me a negative x. X and negative 1 is a negative x. And x and negative 1 is a negative x. Now remember, these are multiplying. Let's see here. 1 and x gets me x. Negative 1 and 1 gets me negative 1. Negative 1 and 1 gets me negative 1. Negative 1 and 1 gets me negative 1. This is going to repeat the whole way through. So instead of me repeating it over and over again, I'm just going to fill it in because nothing is going to change. And just like before, we count what we have. Now we count a little different because things are going to cross each other out. All right, I have 1x squared. Now this minus x cancels that x. This minus x cancels that x. This minus x cancels that x. So I have x squared plus a 2x equals, or plus, x squared plus a 2x minus a 1, 2, 3 by 5 gives me minus 15. And just to verify that this actually works, I'll show you that if you were to FOIL out, let's say this, we would get the same result. So here I have my x plus 2, and I'm going to multiply it by my x plus 3. So I'll go firsts, outers, inners, and lasts, FOIL. So I get x squared for this, plus 3x, not very good, well written, plus 3x, plus 2x, plus 6, 3x and 2x, that gets you 5x. So I have x squared plus 5x plus 6. So again, we get the same thing either way. But the advantage of this is once we start to recognize the pattern, we will be able to visualize this in our head and get to this result much quicker. And I will end this on the following observation, or the following question. What pattern do you see in this picture and how it relates to this expression? And in this picture, how it relates to this expression? And finally, in this picture, how it relates to this expression. So I'm going to go ahead and end this lesson here. Again, it wasn't meant to be a very difficult one. It's just drawing quadratics, and we're going to learn how to reverse engineer it. And we'll start off with a picture and then find the side link. So I'm going to go ahead and end this here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.